All right, gang. We're going to be talking about histograms, and we're going to be on page 26 or thereabouts, 26. So I'm just going to jot that down here. Just for your own reference. Page 26. Okay. What we're going to do is make a histogram. We're going to talk about it and what it means. First thing we're going to do is check out the question. It says, how well did the students of Mrs. Pumpkin's class do on the statistics unit test? So here are the scores that all 28 students got on the statistics unit test. So what we're going to do is we're going to use those scores to create a histogram. We have our intervals already set up. It's going up by tens. You can see here, so the different intervals there. And we're going to put these scores in those intervals. So 72 would be 70 to 79, 97, 90 to 99, and so on and so forth. So I'm just going to kind of put these in here. And then we'll talk about the frequency, and then we'll start making the histogram. I'm going to kind of do these a little quick, but again, I'm crossing them out as I go just to make sure I've counted all the numbers, to make sure I didn't leave one out, because each data point is valuable in summarizing the data that was collected by Mrs. Pumpkin's class. What a name that is. And Halloween must be a special time in Mrs. Pumpkin's room. Okay, 72. So we've talked about in class how you cannot see individual data points in a histogram, but it's important to remember that you need to start with individual data points in order to make one. So we're seeing the data points here, but once we make the histogram, we won't be able to necessarily see all these individual test scores. 89 and then 97. Perfect. All right, so your frequency should be the same as mine. I got 2 in the first interval. 70 to 79 had 5. 80 to 89 had 10. 90 to 99 had 11. Now let's just double check that. 2 plus 5 is 7. Plus 10 is 17. Plus 11 is 28. That's a total of 28. And that's how many total test scores we have here as well. All right, let's make the histogram. So what's nice is we already have the intervals written out. We already have the little lines here, okay? And make sure you have a ruler or a straight edge. It doesn't have to be a ruler, it just has to be a straight edge you can use to draw a straight line. We're going to use that straight edge to make the histogram. All right, first interval has 2 data points in that interval. So what we're going to do is, starting at this tally right here, or do this little dash, we're going to make a bar, or the beginnings of a bar, that is 2 in height. And then we're going to make the top of the bar. And, of course, the other side of the bar. So there's a bar of 2. Well, let me back up here because we don't have the frequency yet. So we're going to start with 0 here. I kind of made an assumption that we're going up by 2, because if we went up by 1, we could only get up to 7. So we're going to have to count up by 2s. 2, 4, 6, 8, 10, 12. Because the highest number we have to get to is 11. Counting up by 2s will help us get to 11. I apologize, I skipped that step at first. I just got too excited to make the histogram bars. All right. So first bar, again, is going to go up to 2. It's going to be the same bar we just made. We're going up to 2. Going across. And then down. And that's going to be our first bar. So that shows that there were 2 test scores in that interval. All right, next one, 70 to 79 had 5. So I'm going to put a little dash here at 5, just to kind of tell me that's where my bar needs to be. So 70 to 79, I'm going to go up to 5. Up on this side to 5 as well. And then I'm going to connect the 2 sides like so. All right, 80 to 89, same sort of deal, but I'm going to go up to 10 instead. starting at this dash here to the right. Go up to 10. 10's, already has a dash there, so I didn't put a dash in the middle of the line. And then there's another 10. Connect the 10s. There's my bar there. Last but not least, 90 to 99. So that's going to be 11 test scores. We're going to go up to where 11 would be, which is about right there. Other side as well. Going to go up to 11. Connect the two lines to make the bar. It's a little short, so I'm going to actually redo that one. This should be good. There we go. All right. Now, before we move on, there's a couple things we have to do. First, we're gonna title the histogram. So the title of this histogram might be like Mrs. P's statistics. That's an S, by the way. Statistics scores. Okay. All right. One other thing we might do is at the bottom here. What do these numbers mean? These are the test scores. I'm just going to label that. That's test scores. And what might these numbers mean? These are the frequency right here. Frequency. Now, before we move on, we're going to answer some questions about this histogram. Let's just label the numbers for each interval. First interval is 2 data points in that interval. The second interval is 5. This will just help us see the data a little bit more easily. 80 to 89 is 10. 90 to 99 is 11, which was 28 total data points. All right, which interval had the greatest number of data points? Well, the interval of 90 to 99 had the greatest number of data points. How many students scored an 80 or above? Well, here's where 80 would be. 80 or above. So 80 to 89 was 10. We also include 90 to 99, which was 11. And 10 plus 11 is 21 students. So 21 students scored an 80 or more. We don't know their exact scores anymore because we can't see the data, although it's right up there. But in the histogram, that's all we can tell about how many scored that score or above. All right, let's describe the shape of the histogram cluster. All right, so there's a cluster. I would say the cluster is probably these two intervals right here. Okay, there's a lot of data points between 80 and 99. So there's a cluster from 80 to 99. Let's talk about gaps. There are no gaps. There's no space between the data or intervals. So we'd say there are no gaps. There are no gaps. And we kind of answered the last question earlier with a peak. The peak is where there's the greatest number of data in an interval. So the peak would be 90 to 99. You'd say there is a peak at 90 to 99. Okay. All right, let's check out a couple more histograms, and then we'll be all set here. Let's go to the next page. So we're going to see a histogram here called distance to work. It says this histogram shows the distance to work for teachers at Spatula Middle School, which is a middle school named after a unique kitchen implement, Spatula Middle School. First thing we're going to do, we're going to label each interval. The first interval is 1 to 10 miles from work. It's going to be 8 teachers. 11 to 20 miles, 19 teachers. 21 to 30 is 15. And then 31 plus is 7. Okay. How many people travel greater than 10 miles to get to work? Greater than 10. So that would not include this first interval. It would be 11 through 20, 21 through 30, and then 31 plus. So it's going to be 19 plus 15 plus 7. Well, 19 plus 15 is 34, plus 7 is 41 people. So if we add up those three intervals, that tells us that 41 people travel greater than 10 miles to get to work. How many more people travel 21 to 30 miles to get to work than 1 to 10? Well, 21 to 30 has 15 people. 1 to 10 has 8. So to find how many more, we would subtract 15 minus 8 would be 7 people, which seems like a lot. 21 to 30 miles is quite a distance to travel every day. Okay, if traveling 20 miles or less to work means you live close to work, do most people live close to work or far from work? How can you tell? All right, 20 miles or less is close to work. So 20 or less, how many people is that? That's 19 plus 8, which is close to work. And that's 27. This is close, by the way. This is close. Far is everyone 21 miles away or over. So that would be 15 people go 21 to 30, plus 7 people go more than 31. So that would be 22. So do more live close to work or far from work? It seems like more live close. And there's not a lot of room here, but I'm going to write more live close to work. To Spatula Middle School. All right, last question here of this histogram. It says, can you find a measure of center? So what it's saying is, can you find the mean or the median? And the answer is no. Why can you not find the mean or the median? Because, and we've said this before for other histograms, we don't have individual data points. We just don't have them. Individual. We had, in the previous histogram, we started with individual data points. And then we made the histogram and you couldn't see them anymore. We'd have to know, like, each of these people, I think there's 49 people in this represented in this graph. We need to know each one of them to be able to figure out the mean or the median. Okay, so that's the end of that one. All right, last one here. We have a histogram showing the career goals scored by members of the hockey team, the Olean Grapes. What a name that is, the Olean Grapes. Okay, describe the shape of the histogram. So, clusters. I would say that there's a cluster. I'm going to highlight it, even though it's already like right here. There's the cluster. So there's a cluster. There's a lot of data between 45 and 59. Cluster from 45 to 59. I'll be right back. I'm just going to pause because I have a special guest. Okay, I'm back. All right, so there's a cluster from 45 to 59. That's where there's a lot of data in a small space. Oh, there's a gap here. There's a gap. There is a gap at 30 to 44. There's a gap there. 30 to 44, there's nothing there. That's a gap. And then there's a peak. The peak is, and that's the highest number of data, 45 to 59. All right, now, before we go on to the next couple questions, let's just write down how many data points there are for each interval. 15 to 29, there are 25 data points. So that means 25 players scored between 15 and 29 career goals. 45 to 59 is 42.
And then 60 to 74 is, excuse me, I'm going to say 12. If you said 13, I wouldn't hold it against you. All right. What interval is the greatest number of data points? Well, 45 to 59 is the greatest number of data points. How many players scored 45 or more goals? Well, that would be, I guess right there. It's a giant line there. It made it again. Let's see if it makes it again. Yep. So it's going to be everything from here on, 45 to 74. So that's going to be 42 players, which is this, plus 12 players. So that would be 54 players. Okay, what information can you get from a line plot that you can't get from a histogram? Well, with a line plot, you can find the mean, right? You can find the median, which is the measures of center. You can find the range, which is the distance between the greatest and the least. You cannot do that with histogram. You can find the mode as well, which is the most popular data point. And then, you have the individual data points. So you might be thinking like this might be the mode, 45 to 59, but we don't know the individual data points. So we wouldn't be able to tell what single number came up the most in the data. So these little measurements here, you cannot find using a histogram. Okay, I hope you enjoyed that. Hopefully it made sense. And ask me any questions. Send me any questions you have. And if not, I hope to see you soon. Have a great day. Bye-bye.